Yay, we're up and running.
Good. Now recording.
Now record. Oh, might stop sharing my screen. I think it is sharing my screen.
You don't want to stop sharing your screen. You want to record.
It's recording.
It could be. I didn't think it always recorded.
Okay, so I think that's it. In fact, I think if you come over here and refresh this, we'll see that stream.
Has a direct cloud service for your live stream?
Yeah,
Google Plus does. It's Hangouts.
Oh,
The Hangouts will stream it live and we'll record it for you if you click the right consideration buttons. But the stream is offline. Right stream.
it says stop broadcasting when I talk. There's something there and it says live. Where are you saying the stream is offline?
On the other screen when you're looking, you
Well,
have five.
Yeah, you're right.
What I'm asking is that the right screen?
It may not be.
You probably have it on the URL.
Let's see.
Upload a video. I guess it's cool.
Do you see where to see it? You don't have a laptop out. You don't have a laptop, period. Well, that's not really helpful.
I would figure I'd just use one of the 6 that you brought.
Oh, well, I already got that. All right. Okay, yes, we are live. I really hope we are going to edit this because it really needs editing.
So,
Yeah, this is going to be awesome. Let's see. I need to close that window. There we go. Okay, I think we are ready to go. Yay!
Yay.
All right, so we're going to talk about that probably. All right, so today we're going to talk about unit testing, everyone's favorite topic, right? All right, so let's start with this. So who writes as many unit tests as they should, or tests in general? Anyone? Okay, tests in general. Well, you know, as many tests. So let's lower the bar a little bit. Who writes most of the tests that they think they should be writing? You're not even going to raise your hands?
I write more tests than anybody I know, and I don't write near as many as I should.
Okay, who writes about half as many as they should be? Okay, we got a hand. Who writes 5% what they should be? Yeah, okay. Who's never written a unit test ever? Anyone? Hey, we got some hands. This is awesome. So hopefully, I'll make some converts out of you. Because unit test is a little bit like religious. And we have all kinds of excuses to not do it. So there's a lot of reasons we may not. I find the biggest one is people don't know how, honestly. They don't have time. Their code isn't written in a good way that's testable. They don't think that their employer wants them to do tests. They don't plan for it when they estimate. A lot of reasons, right?
It doubles the amount of work that you do.
I hear it doubles the amount of work that you do all the time.
I don't know how it doubles the work.
I don't know how it doubles the work. That's what you hear. Well, let me try and assuage that notion. So if it's really important, you'll find a way. So my goal here is try and convince you that unit testing is really important, and also that it's not as bad as it may sound. It's not really double the effort, etc. So that's my goal. We'll see if I get it. So what are some good reasons we write unit tests? Now, we all understand these reasons, but let's kind of go over them. So the first and foremost, it forces you to make better design choices. So for example, we use loose coupling on different tasks rather than, just welding those things together, tight coupling. Because when you tightly couple, what happens? Doesn't work very well, does it? All right. Our code will be faster. Now, I say you will write code faster, and people like, no way, you're writing more code, it's not going to go faster. But let me put this in front of you. How many times have you had to log into an application to test some little function clear down here?
Oh, I don't have the data to do that. Can you get me some data? Haven't anyone else today?
Data to get that, exactly. So I can get running this little bit of this new code I tested. I can get a unit test up and running in that in seconds, maybe before you even pass the login screen, and I can certainly debug it quicker. So I would propose that it may be way faster. And just in a project I saw today, some of the setup for one of the tests took 15 minutes to get to the app to the right point where they could test one little bit of code. Well, why not skip past all that, right? And another one is have confidence of whether the code's going to function. That could be important if we're like writing aircraft software, medical software, where people's lives are at stake. It could be important if we're dealing with people's money. And like I have on the last point here, it could be really important so we don't look like an idiot when we push this thing into production and it doesn't work. Yeah. And there's other really good benefits too. For example, we can have maybe someplace a documentation of the requirements if we notate the requirements as part of our tests. It's really great for continuous integration, i.e. we know when we check in code whether we broke a bunch of other code. And also when we're swapping out large bits of framework, we can be confident that we didn't break a bunch of our code. So a lot of benefits to unit test. Consider this about, according to, name escapes me, Steve, I want to say Conan, but that's not right. This Microsoft guy, come on, help me out here. 70% of the software development lifecycle is refactory maintenance. Well, that makes some sense to me. What's that? That's the one. Thank you, Steve McConnell. Extra points for 70% of the software development lifecycle is refactory maintenance, and which makes sense to me because if only 5% of the software is refactory maintenance, then that would mean we never launched anything. And if 100% of the thing was refactory maintenance, means we probably did a really bad job. But yeah, about 70% of it is maintenance. So why wouldn't you invest in making that refactory smoother? And also another good thing is poorly written code costs a lot more to run and maintain. And if we know we were going to write better code when it's unit tested code, then we can say, well, the code we're writing as a result is much better code. So I kind of have the large code base effect. After so long, programming with bad architecture will be impossible to add new functionality without actually just rewriting the thing. And I've actually seen this in software. You've worked on a project before, I'm sure, where everything's just kind of a big ball of mud. And to add a feature is going to take an act of Congress because you've got to move a whole bunch of crap just to make space for whatever you're trying to add in. I had this recently. I was tasked with taking a piece of software that connected to a USB device. And every once in a while, that communication with that device would kind of time out and stall. So all I really wanted to do is be able to restart the connection and continue if it did stall. The software was not written in a good enough way to do that, and it was impossible to do without short of rewriting the whole thing. So just kind of keep that in mind. Okay. So yeah, why wouldn't you choose to do everything you can to have this nice, clean code? And good architecture always yields quicker implementation. So let's start with the basics. The first thing you should know is the acronym FIRST. That is, tests should be fast. That is, they should execute fast. They should be independent. That is to say that no one test should be required to be run before or after another test for it to be run. Shall be kind of isolated. They should be repeatable. Kind of similar to what I just said, wasn't it?
No random data in your input.
Yes, that's great. They should be self-validating. That is, it should be obvious that they're doing what they're supposed to be doing. And timely, meaning that you should be writing them when whatever the code you wrote is fresh in your head. Because a week later, and you think you're going to write unit tests, or you think you're going to write the whole project and go back to and unit test it, that's not going to work. Not simply because no one's going to have the will enough to do it, but also because while you're in there, while your head's in that code, in the game, you know the edge cases, you know the inputs, you know the code better than when you try and go back and relook at it. It's not going to be the same. So you need to write these tests right when the iron's hot, if you will. Okay, next thing you should know after first is always follow the AAA model. So the AAA stands for Range Act Assert, and that's just simply saying that it is polite convention in unit tests to have a section at the top where you arrange all of your inputs, your outputs, your variables, your test doubles, anything you need to run the test. Then act is your actual running of the code, and then assertion in order to make sure that what you're testing actually happened. Now in unit testing, I'll say this again, in unit testing, we're only going to do one logical assert per method. Now, that may seem like a somewhat ambiguous term. What I'm trying to say is you should at least have one assert. A test without an assert is really nothing. In addition, you should use as many asserts as it takes to show that whatever you're trying to prove does indeed happen. So you can have multiple assertions. But you shouldn't like try and roll 4 different test scenarios into that one unit test. The reason being, you want to, back in the first thing, you want the self-validating, you want to be obvious what's wrong based off this test passing or failing. And if that test actually handles 10 or 12 different logical assertions, then what you've done is you could say narrowed it down to 10 or 12 possible issues rather than one possible issue.
People come to me a lot with questions on unit testing. One of the things right in this area that I always point out is the name of the test should tell you definitively what went wrong if it failed. You shouldn't have to go and look at what the exception message was, you will, but the failure of the test should tell you by its name what went wrong. If it does more than one thing, it can never do that. So,
excellent.
Yeah.
Okay. All right, so let's talk about unit testing for a minute. So I've got a little piece of code here. It's probably a little small, but you can probably see a little bit. Take a look at that and try and guess in this 10 lines of code here, how many assertions, logical assertions there may be, test cases, if you will. Guesses yet? We got a 3. Anyone got more than a 3? You're still counting?
Yeah.
What do you got right now? So I can get moving.
Well, I would have to write it down.
Yeah.
I'm well over 10.
Okay. So one of the reasons I want to post this example is it seems to be a common pattern sometimes that people write a unit test per method. That's not unit testing. It could be one unit test per method, but that's not what unit testing is. Unit testing is testing all these cases. So you can see in this case, we've got one test scenario, we've got 2 test scenarios, we've got 3 between them, we've got 4 test scenarios, 5 test scenarios, 6 test scenarios, 7 between those, 8 between those, 9 between those. There's a ton of test scenarios in this thing, and it's just a few lines of code.
You've got 3 inputs that can be in any one of 3 signs, just for starters. A, B, and C can all be negative, 0, or positive. And you've got zeros in there as part of the comparisons. You've got greater thans and less thans. You know, just by counting the inputs and the outputs, that's 9 tests.
Right.
And it just goes up from there.
There's at least 8, probably many more, right? So how many units of work is this? How many unit tests do you think this ought to be? Yeah, exactly. All right, so let's move on a little bit, and let's talk vocabulary. Now, I'll just put out here to begin with, it seems as though we haven't all agreed on vocabulary at this point still yet, but we seem to be coalescing around some terms. So I've only included the ones that I think we have fairly well defined. There are, of course, others, but let's start at the top. So a test double is kind of a range of objects that include anything that's going to act as a dependency for the test you're going to run. So that can include test stubs, which are just simple objects that mimic what a real dependency might do. It might include a mock, which is a bit more complicated object that allows us to assert more carefully how that dependency might have been used. And we could use proxies and fakes, which are a way to redirect kind of what it thinks it's going to be getting as a dependency to something else. Okay, and we'll talk about all these in a little bit more in our examples. And then seams/boundaries, and that's just going to be logical separation of the code. One of the things you want to do when you unit test is you want to test mostly around these seams. That is to say, you don't really want to go and test this private member of this class because, well, frankly, it probably needs to be, it's probably going to be exposed through some other functionality, right? You can test it if you feel like, well, this is like a date calculation. Date calculation is part of a more complex calculation. It would be kind of difficult to unit test it. You can unit test those things, but it's probably better to test it along the seam. So also, if you had something that was that complex, maybe it warrants being its own object. So, okay, more unit testing vocabulary. TDD stands for test-driven development. We call it red light, green light because what happens is you write your test first with an assert fel at the end, and you simply generate the code as you get the test working, and by the time you have all green lights, you're done. You don't have to write any more code. So that's why they call it red light, green light. BDD is behavior-driven development. So it combines some principles of test-driven development, also domain-driven development. And the big idea behind BDD, as we'll see more a little bit later, the big idea is that we're going to unit test actual requirements. Like these are end-user requirements that we're going to write tests to make sure assert that. Now, the difference between testing requirements and testing a unit of something is maybe subtle, but it's more like a unit of something may be a requirement, maybe a piece of a requirement. It may be a couple of requirements together, but testing a requirement is pretty straightforward. Like I said, we'll look at that more a little bit later. Regression testing, that's a test we write when we fix a bug and we want to make sure that this bug doesn't happen again. Regression tests are a really good idea to get in the habit of doing. Anytime you fix a bug, great idea to write a unit test to check to make sure that bug doesn't appear. Recidivism among bugs is quite high unless you write tests for it. Acceptance testing, we're writing specific requirements to work according to specifications. Integration testings, we're going to take 2 or more bigger pieces, modules, and make sure those 2 work together. Function testing is making sure the application works, i.e. a function of the application is working kind of from a top whole system approach. Those slides are out of order, aren't they? Oh well. And then there's, system testing. I think we talked about that. But we're going to, essentially, this is like our testing the UI all the way down to the database, the whole stack. Stress testing is pretty self-explanatory. Acceptance test, yep. All right, so the idea is that the smallest thing we're asserting tests are unit tests, and we have integration tests, which is testing several units together, several pieces together, and we have system testing, which is testing the whole stack. And yeah, any questions there? Yeah, good. All right, unit tests and axioms. It is very difficult to test bad code. Bad code being tightly coupled, multi-purpose type code. This is a very true axiom, but there's ways around it. We'll see. Should I write other kinds of tests other than unit tests? Should I be writing integration tests? Should I be writing system tests? Absolutely. It's kind of like this. If you're building a car, it's one thing to test that the motor works. It's another thing to test that the blinker works. But to test the whole system together is something entirely different, right? To drive that car and make sure it works, very different. Should I copy and paste all my unit test code? No. So sometimes people get confused and think that in unit test classes, the only methods they can have in there are test methods. This is not so. You should have other bits of methods, helper functions, whatever you need to make it so your tests are clean, i.e. easy to maintain, because this is code that you're gonna have to maintain, but also that they're well written. Use good coding techniques. Should I write a unit test for every time requirement? Yeah, because if they made a requirement, then they probably meant to have it work that way. And then I have a little example here. This is actually Phil's example. If you want to talk about that for a second, Phil, that's not looking.
I'm listening now.
I don't know how you're going to talk about this example if you don't know what example is.
Fine. I can't see it. Here it is. Just one step there. Oh, gosh. Yeah. All right. So,
Is it worded here?
anybody see the problem? Well, the guy who wrote it didn't. So the problem is that the guy wrote it in 10 different places. So when I went to replace them, I went and put them in a function and wrote a unit test for it. And so whenever I encountered this bug again, I knew that there was a place where he put this that I didn't refactor into my function. But the problem that this guy had was he just assumed that he did it right. And I'll just explain it here. The idea is that if a person owes less than $5, we don't make them pay it, we forgive it. It's called toleration. And what he's got there is if the amount that they owe is greater than -5, which is true for all positive numbers, or it's less than 5, which is true for all negative numbers, then it pardons everything, right? If he had just taken a moment to write unit tests for the toleration unit, he could be sure that calculation throughout a 3 million line application was always correct. But he didn't bother. Oh, yeah. So, I mean, it was the original code, but it made it to production. I'm serious, and we have a team of 10 people in the business who were, three were people who were required, who were responsible for testing, meaning that they delegated to the actual people who do the job for a living. And said, here's a test version of this, walk through your daily routine with this application, with this new version of the application using real data, real clients, and tell us what you encounter. Nobody ran into this problem during the testing. We shouldn't have ever had to go that far. None of those people would have been as effective. All 10 of them wouldn't be as effective as one unit test. And he looked right at that 10 times and didn't see the problem. You have to write the unit test to make sure that what you are sure of is correct. He was sure, so why should you write a unit test? There's the reason.
Yeah. Thanks. All right, so we're going to do a real quick demo here, just basic unit testing stuff. Also answer any questions you might have as I'm doing it. But thankfully, back in Visual Studio 2005, they have restored a function that I've been kind of missing, and that is we can, again, like we could in the past, right click and say create unit tests, create a unit test project and all that stuff. I'm not gonna do it now because I have it one created, but this can be an easy, if you just want to create the project, get going, right click, and it's done. Okay, once you have the unit test project done, go into our simple unit test. Kind of show you around a little bit. So the first thing you'll notice is I got this new class, and it's got this test class attribute on there. And the class that we have must have the test attribute. In this case, we're using MS Test simply because it's built in. But NUnit has the same fixtures, they're just called something slightly different. All the unit testing frameworks do pretty much the same thing. And then inside the test class, we have these test methods. And these test methods are functions that are parameterless that will help us determine something. So we're going to do a unit test here. So before we write our own test, let's look at this test. So you can see I'm following the 3 A's. I actually explicitly write out in a comment arrange act assert.
Oh, good. It's not just me.
I've been told that that's a little silly.
It's great.
But yeah, I mean, the second you go to try and put like an assertion line inside of the arrange or something, like, oh, this doesn't belong here. Where it's a lot easier to forget.
Well,
I recommend putting comments. Yeah.
It strikes me that that would also be a great way of getting your development culture in sync. Because the new guy, like myself, for example, in this particular area, okay, I see that.
Yeah. So, and the range, I range everything. This is everything we need to run the act. Act is almost always one line of code. That's how you know you probably did it right. But I mean, think about some of the stuff I have over here, though. The score that I'm saving later, it's up in a range, just a variable declaration for it. I could have put int right here, but the convention is to put everything that you're arranging up here. The expected value, well, I put the expected up here. I could put the expected right in line down here, but the convention plus we want to be able to quickly know this is where I go to look at the parameters of the test rather than, you know, checking out each and every assert. And then you can see I've got a logger stub. So we talked about stubs, so let's look at that real quick. So this is my logger stub. Very fascinating. I simply inherited this, did the bare minimal that required to compile because I'm not actually going to assert anything off it at this point. So this is my stub. And that's typically what stubs are. If there's property values that you need to actually get and fetch, then you probably put a real property getter setter there. If there's methods that actually return values, typically you just return the default of that value or null or whatever you think that the test should return. Sometimes you get a little bit more complex with these things and you can put in, hey, I want it to return these pieces of data when I run this test as kind of a setup, that kind of thing. They can become quite elaborate, but they don't have to be. They can be very, very simple, and they cover everything in between. You kind of want to say something, so you want to add?
Well, usually my stuff's aren't too like this. If ever I need one that actually returns values like that, the answer is not always yes, but I always ask myself, should this be a data-driven test? Because MS Test supports data-driven tests where you see where he's got, not here, but in the unit test, he's got attributes that tell what the test classes are, what the test methods are. There are attributes that slap on there that say, for every time they encounter this test, run it once with this set of data, that set of data, that set of data, and you can just give it sequences.
There's some debate, though, whether data-driven tests are really unit tests.
There is that. Like I said, the answer is not always yes.
Also, MS Test and NUnit do a bit differently. And MS Test expects an OLEDB connection to like a CSV file or some other piece of data. In NUnit, you can actually attribute or annotate the actual test data in annotations.
So
Yeah.
That's what
All right. So then you can see I have my target here. It's player score. And then I have a little bit of setup I have to do for it to actually get the test to run correctly. So once I've done my act, this is the calculation I wanted, I do an assertion. So let's actually run this to see how it works. So I'm going to F9 to get a breakpoint, and I'm going to do Control-RT for run test. get rid of that. All right, so I'm in my test. I can step. Maybe I'll step into here. Looks good. Come back out. Maybe I'll step into there. Looks good. And then I'm going to ask for the score. Got a score of 10. My expected is 10. I think that worked. Well, I know it did because I got the last line, but I wanted to be sure. I would go to my trusty little test explorer, and it'll show me, yes, indeed, this test passed. And how long did it take to run? 26 seconds because I stepped into the whole thing. Yeah.
Well,
It's called the test runner.
It's not an express version, is it?
Yes, test runner?
Really?
Yes.
Excellent.
So while you bring up the express version, let me tell you the thing that really sucks about MS Test is that there's a feature called test lists or playlists, depending on what version of Visual Studio you have. They used to be free for pretty much all SKUs of test, and then the test version just kind of had more advanced scenarios like load testing and ordered testing and things like that. But they took it out starting in 2012, I believe, the 2012 version. So the reason the test list is really handy is that's what you're going to run when you run MS Test in a continuous environment version. So you have to find some other way to run them. Typically what I've been doing is just passing in, hey, run these DLLs and get all the tests out of there. And then also we want to screen some of the tests out because we don't want to run integration tests or whatever. So you can add test category to these tests by, there we go, saw it a second ago. Test category. And I can put in new something. I can put in a category here. And then when I build and then look at my test explorer, I can do by traits. And then I can go look for my new something trait. There we are. We can also discriminate unit tests based off of those traits as well. So if we wanted to mark these, like use the test category and say this is like an integration test, and we don't want to run integration tests in our continuous environment, this is a good way to do it maybe. It's not the only way. They could be in separate projects, for example. But anyway, okay. So let's write a unit test. So I usually start with the test method, attribute out of the way, then public void test for out of range to low number. Okay, so we got a nice descriptive thing. You may use whatever casing works best for you and your team. I personally don't like the underscores in test names, but if you're going to put underscores in method names, the test names is probably the best exception I can think of. And so we're going to do range act insert. So this is going to be a little bit different. I'm going to kind of show the test and the feature. So I'm going to grab me a logger. So var, or what? Okay, and then I'm going to give me a target. Okay, and I'm going to act. Yeah, I'll get current store with -1. See, what I'm going to do is make that -1. Okay, and for now, we leave my assert blank and let's run it and see what happens. So I'm going to F9 here, run test. Go ahead. Okay, so we're in my test. I'm running. Oops, what happened? Everything is shut down. Well, nothing over here. Just kind of see. Let's do, there it is. Just kind of shows that it failed. Oh, wait. I got an exception. And so it failed it. Well, that's all good and stuff, but what if we were to be able to actually assert that the exception happened, the right exception happened, right? Because any old exception causing that problem, we may not know. So there's an attribute, exception. So we can say type of arbitrary range exception. So this basically says if I get any other exception than this, then the test actually fails. But in general, we want to be able to have this test passed because it's doing what it's supposed to be doing. We're testing that we're going to get an exception when we do something stupid. And so we go to test runner. Ah, there we go. We got the exception we expected, therefore it passes. But if I change this to just, you know, some other exception, and I run the test, got the wrong exception, didn't pass. Cool? All right, so let's put that back. Any questions at this point? Range act assert, first, all that stuff, test mocks, test doubles. So let's go back to the slides for a minute. What was the button for resume slideshow?
Is it Google? It's F5 to start.
Okay. So let's talk about a second about mocking. So mocks are a specific kind of test double. In general, the idea behind the mocks is that we want to not just give a dependency to our object, but we want to have some information about how that dependency was used. Because maybe how that dependency is used is what we're testing. Or maybe how that dependency is used is a part of the assertion, logical assertion that we're going to be making, that what happened correctly, right? So mocks are very awesome, very handy, blow your mind, their capability type of object that we can use in testing. And in fact, another great thing, so what we're going to demo here is a framework called MockU. But oftentimes we use dependency injection in our projects, right? And oftentimes we can use a mock or MockU even that caters specifically to our dependency injection container. The reason that might be helpful is if someone's using like a service locator in their code or something, and you still want to be able to test that, well, you can set up that service locator through the MockU framework to provide these mocks, these pre-set up mocks for objects when they're required. Anyway, so let's do a quick demo of the mock. So to get started with MockU, what you'll want to do is you'll want to go to the references here, and you'll want to say NuGet packages and just MOQ. And then here's the mock. Now, if you're doing some special things, you may want to look for other things. For example, there is a mock for Entity Framework that does special stuff to help you test any framework under the mock framework. If we wanted to do MockU with Unity, there's Unity AutoMock. And yeah, so once we get that, for the purposes of this though, we're just going to stick with regular mock U. So once you got that, you're ready to go. So here's my new test. Now this is pretty much the same test I have as this first test, but instead of the stub, I want to use a mock. Because if I come in here and I look at this score property, score property calls get current score, which is defined here, and get current score actually uses that logger. If there's a strike or a spare, it'll log something out. And we want to be able to test that that is getting logged out. Maybe there's some requirements that logger logs those messages. So we're going to take a look at that. So let me actually close some of this stuff here. This is how we do it. So we say new mock of type that we want to mock. And there's two mocking behaviors. There's something called loose and something called strict. Loose basically says that if there is something I haven't actually set up yet, just go ahead and run with it. Just go with it. That is to say, if I call a method, if it calls a method that I hadn't set up, then just return default value. If it returns an int, then it's going to return 0. If it's returning an object, it'll return null. That kind of thing. Or if it makes a function call, good. Let it make the function call. You know, if it gets a property, let it get the property. Sets the property, let it set the property. So that's kind of how loose works. Strict, on the other hand, if you try and call anything you haven't explicitly set up beforehand, it'll throw an exception. Okay, so this is the kind of the language here. It's kind of a fluent syntax, but let's kind of step through it. So I'm basically saying, with this mock logger, I want to set up, and this lambda is basically trying to pick what it is I want to set up. Now you'll notice log message is something that is a method that takes a string as an input. Well, because of this lambda, I actually have to give it some kind of string as input. So I typically use this it is any string. Now there's other things I could put here. For example, I could set it up such that if it passes me this particular value, then this is what I'm going to set up. Or if it passes this other particular value, then I want to set up this way. But I'm just saying for anything, for any value of string, and then at the end of here, I'm saying verifiable. What that's going to say is that I want to make sure that this gets called. That is to say, I want to make sure that log message is called during my act. And by saying it's verifiable, then later at the end calling verify all, this will tell me whether that happens or not. And so there's more we can do here though. Instead of verifiable, I could say returns. Well, callback, which gives me an opportunity to provide an action to actually return a value for it. I.e., I'm going to implement just a mini method to return something for it. I can do raises exception. Sorry, is that right? Raises exception. Throws exception is throws. Specifies that will be raised when the setup is met. Okay. Also, in the verifiable, I believe, if I'm not mistaken, I can say how many times we expect this to be called. Oh, that's Rhino mocks. Sorry, I'm getting my mocking framework backwards. But I can give it a message, so that's kind of cool. I can set up other things too. So if I do logger dot, I can do set up properties. I can set up getters. I can set up setters. I can verify getters, verify setters. I can do when, which is going to give me a chance to do a particular condition. When this random condition is met, I want to do something, that kind of thing. So the flexibility here is really endless. And honestly, I'm not an expert yet. I use mocks a lot, but I have still yet to learn a lot about them because there's still so much to learn and do. But for this example, we're going to make sure that our logger gets called when we have the right inputs here. So I am going to pass 9 into here, and I'm going to expect 9. But 9 will not be a strike or a spare, right? So what I will expect to see is a fell assertion here. So let's do that, right? So it's F9, oops, F9, F9. Can't say F9 there. Run test. Okay, so we're going to step through this. In the score, they are equal, so pass that assertion. We expect 9. We got 9. But wanted to hit the verify all. You can see we got an exception that the following setups were not logged. So it probably is a really good idea in here to put your own error message. Okay. So let's repeat it with the message. See, here's my message here. Calls for giving inputs. All right. Any questions on logger? Mock. Any questions on mock? Or mock you? Mocking. Machiavellian.
Mock yourself.
Mocklet. All right, let's move on. Okay, so there's also something called shims and fakes. Now, you ever go and unit test something, and here's the two most common I run into. Part of that method has datetime.now, or maybe part of it uses the file system or the registry or any number of these things that are just kind of resources that people typically don't, but maybe should. Extract into its own interface. It happens all the time, and it makes code really difficult to test when we have stuff like that. So there's the idea of in .NET where we can shim stuff. Now, originally this was called moles, and that's why it's labeled moles here, and that's because that's still how I understand it in my head. But let's go look at how we do that. So just for fun, in this example, I'm going to add a method here. Days. And it's going to return datetime.now.today, or let's see, time.today.add. No, let's see. Add days. So 10 days. Month. That doesn't make any sense. I know, it's okay. So now we have something we want to test here, but it has date time. How are we going to test that? Well, that's easy. So what we're going to do is come back to our test over here, and we're going to set up a test fixture for it. Okay, and so we're going to do that was a poor choice of name. Oh, shoot, you bet. Should have said something earlier. Is that big enough? Okay. So let me skip quickly to the act because I don't want to spend too much time on this, but it's kind of cool. delegate days. And I'm breaking a little bit of my own document here, doing this example just to hurry it out. But now the problem with this is that, so if I remember the test correctly, we can assert R equal, work should get 11, because 10 days from now, it's still November. So let's just run this, make sure that that does indeed run. Okay. Yes, it does run. The problem with this test, obviously, right, is that in a couple weeks, it's going to fail. That's no good, right? And so we could either keep on updating this, or we could try and, guess in our unit test what the value should be and then see if they match, right? But none of those are any good, right? So what we want really is a shim. So here's how we do it. We go to our references, we go to the assembly that is we want to shim, we right click on it, we say add fakes assembly. It's going to take just a second here. And what this is going to do for us is actually kind of cool. But it's actually going to redirect any call to date time once I finish getting set up. System. No, sorry. I just want here. Once I set this up, it's going to redirect any call to datetime.today to this particular shim I'm going to add right here. So now, if I can remember what it's called. So anyone remember what they named these? I always forget. Fakes. Okay, here we go. Time. Dot. All instances dot. No, hang on. I'm doing this one from memory, obviously. Today get dot. Yeah, come on. I know how to do this. So close. Target, delegate, goals. It's not quite right. Well, that would have been a lot cooler if I could remember how to do this. That's the one I want. Well, you set it up and you do it.
This is where you Google it.
Yeah, this is where you Google it. But the cool thing is you can redirect anything. Like another assembly, somebody else's library, you can redirect anything. And therefore, the excuse that you can't unit test because it just wasn't written to test really falls apart with fakes.
I remember the first time I saw the presentation from Olsen PEX, which is the very first version of this, and I was probably more impressed with that than any framework I've ever seen since. It was incredible.
Yeah.
It's good stuff.
Speaking of PEX, I'm not even going to bother switching the full screen because we're going to talk about PEX. So anyone else other than Phil ever heard of PEX before? PEX? PEX? OPEX? TOPEX? Okay. So PEX is kind of cool. What's that?
Did you say Topex?
And I think the easiest way to describe it is to kind of see it. So I'm going to grab this right here. This is a really cool website called PEX for Fun. I'm grabbing a new window and paste it in here. Okay. So PEX for Fun is a little website where you take C# code here and you ask PEX what it thinks this code does. What it will do is actually go through, analyze your code such that any inputs that seem interesting to it, it will display. So actually what this is asking me to do, PEX for Fun is asking me to take these inputs, or sorry, take these inputs that it already has done on an existing piece of code and implement a piece of code that matches it exactly. And if you do so, you'll actually have written the exact functionalized piece of code. So let's do, let's do learn for a minute. No. They usually have a return I, so we'll ask PEX what it thinks. Okay, so you'll see there's very few values for this function because all it does is return a value. But I can get interesting with it. So I could say if I is greater than 0 and return I times I, else return I. So for example, we can ask PEX about that. I am number 1 in the queue. Sweet. How many inputs do you expect? I'd expect C2. That's what it does. It says the interesting values are 0 and 1. So anyway, really cool tool, really fun game, even has a mobile app. Something you can do to church. Not that I've ever done that, or no one I know has ever done that. But let's look at one other thing real quick. So it used to be that you could get PEX to integrate into Visual Studio. And not only would it give you interesting values, but you could create unit tests off those values. Well, it didn't really kind of work too well because the biggest problem was that they weren't really unit tests in the conventional sense. They're more of a unit test that has a bit of data that you spit out in the past. And so it just kind of asserts that the methods match. And that could be useful. But they've since expanded it. So now if I come to here to my bowling example, I find a piece of code that looks a little bit interesting, like this one perhaps. I can right click on him and I can say, create IntelliTest. So no longer are we calling it PEX, we're calling it IntelliTest now. So if I click on this guy, it gives me some options. Yes, I want MS Test. Apparently wants to create a new test project for some reason. That's all right. Say OK. So it's going to create a whole test project, but we probably could add on to it too. Now, that just created it. That didn't really do what we wanted. So let's come back for a minute. And let's click on it again. And let's say this time run IntelliTest. Okay, so this is going to do pretty much what PEX would do. It's going to look at the interesting values that can go into this thing, and it's going to generate some interesting code to go along with it. Now, you can see that it even did pieces of code that expected exceptions. So you can see our expected exception attribute here as we would expect to see.
Say that again.
I don't think I can. But you can also see it found something else that's interesting we didn't expect. there is some values that could be put into this function that would result in a null reference exception. Totally found that. Wouldn't have known otherwise, right? So you can say, oh, geez. Well, you can either choose to say, okay, this is a feature. Let's, patch it. Or we could say, let's change the code and not allow that, something. But yeah, and also that allowed it prevented the rest of the blocks of test from executing. You can also notice I have a warning, 2 warnings here. And it's basically saying, hey, you've got this thing called guest player score object, and I'm just guessing that the way I construct it is this way. And it was right. Now, if I didn't have a logger at all even in that class, then it would just pass null and it would still give me the warning. And when I ran these tests, it probably wouldn't work quite right. So I'd have to go and eventually resolve these warnings. But yeah. Okay.
Isn't that cool?
That's cool. Now I can grab these or the whole thing. I can say, oh, I already saved them. Did I already save them? No, it didn't save them. Where do I save them? What else is the thing about doing them live? I'm supposed to be able to do that save function right here. Last 5 times I did this, it allowed it. Not sure what I did wrong.
Just the green ones?
Yeah, it's a good thing to try.
Well, you broke it.
Maybe it needs to go through the whole test.
Let's try it one more time. You notice I did right click and it said allow, and now it's green. So now it's saying, oh, well, you expected that null reference. Good job. And then you're supposed to be able to right click on here and say save. Live demos, right? Okay. It's really cool though, I promise. The tests it creates are nice. They actually have comments, range, act, and assert. Look pretty good. In fact, I've done it in the past, so maybe we've got some code just floating around in here that will have it. It will be in here.
Essentially, it'll go through and fill in where unit test read what it looks like, or at least give you an idea.
Right. Having an idea, so in mathematical terms, it's giving us an idea of the domain and range of our function, which is very helpful. It classifies the function really, really well. It gives us good ideas of what inputs to have. It can even be really good for security reasons, because that null reference exception may have resulted in somebody getting a bowler score above 360. So yeah, it's a really handy tool that way. I highly recommend it, when it works. One thing about the tool though, kind of a bummer, it's only available in the higher SKUs of Visual Studio. Actually, it's the same with the shims. It's only available for the higher SKUs of Visual Studio. I'm not even talking professional. I'm talking like, yeah, the higher stuff.
So is the framework not available for download, and the integration is just in there, or is the whole thing part of it?
So you're talking like PEX and moles separately?
Shims and what are they called?
Yeah. So way back in
Available.
Visual Studio 2008, Visual Studio 2010, you could download them and they would add in, and they actually worked pretty good. But those are gone now. So pretty much the only way to run it now is to get the higher SKU Visual Studio. Sorry. It's kind of a bummer. I would like to use them a lot more, but we only use professional at work, so. However, having said that, if you find yourself using a shim, that should be a clue to you that you should probably decouple that code just a little bit more from that dependency. Just saying. All right. Cool. Anyone have any questions on IntelliTest / PEX or anything I said? Sounds like we're moving on. Good. All right. Let us resume slide. And okay. SpecFlow, finally. So SpecFlow is behavior-driven development style testing. The requirements are actually written in a language called Cucumber, And they should look pretty familiar. So this is an example. So the first thing we see is the feature name. So feature addition. In order to avoid silly mistakes as a math idiot, I want to be able to be told the sum of two numbers. So this kind of sets up the user story part of this scenario, right? Then once we've done that, there can be, once we have the feature, there can be one or more scenarios for this feature, right? So scenario, add two numbers. Given that I have entered 50 into the calculator and I've entered 7 into the calculator, when I press add, then the result should be 120 on the screen. Now, it may seem like it's just free-for-all language, but it's not. So you can tell, for one, anything in blue is going to be a keyword type thing expected in a certain place. Also, you might guess that these numbers are identified and abstracted out, and the structure of the sentence in general actually has meaning. And this will become more clear as we go on. But essentially what's going to happen is we're going to generate these statements as individual methods of code. We're going to implement them, and they can be reused. So that if the next scenario is add two other numbers, for example, we can use the same given and the same and the same when and the same then even, or different parts of it or different combinations of them, and we'll still get the value we expect. Kind of trippy, I know. We'll look at it a little bit. But before we quite get there, let's talk a little bit more about the syntax. So the feature, this is kind of the basic pattern. Feature name, in order to blah, this is user story format, and then we have a bunch of statements that are the scenario statements. So the way to break this down, at least the way I break it down in my mind, the given is kind of like the test setup. It's kind of like the arranging of things, right? So the given is I'm going to set up a bunch of these scenarios for my test. For example, I could say, given I have a bowling score record of this, given I have a calculator object, given I have any one of these things, this is going to help us set up. So these are kind of like setup statements. When some action, this is going to be our act. This is going to be the act part. So we usually have just one when. In fact, I believe the Cucumber syntax only allows one when per scenario. I'm not positive on that. When this action happens, so yeah, this is our act. And then the assert is then and the ands. So then I expect this to have happened, and this to have happened, and this to have happened. These are just a list of assertions. So it's really not that foreign for a unit test, right? If we break it down that way, it's really not that bad. But the great thing is, if you can convince your business people to do it, sometimes you can, sometimes you can't. But even if you can't, you've got tests written out in pure language that describe the feature. So it's not only helping you to be the code of the test, but it's helping as documentation for the test. You said right here that when I have 15 and I have 20 and I add them together, it's going to be 30. Why are you telling me that you want a different result? This is what you said. Those kinds of things. It also, unwittingly, helps weed out inconsistencies in their scenarios. So like I said, we're reusing these blocks of scenarios. So if they have a scenario that says one thing and then a scenario that says something totally opposite or something that's not analogous, not working with it, they'll force them to either change their vocabulary to be a new, different kind of feature, or they'll have to realize their mistake of, hey, I can't have my cake and eat it too. Does that make sense? Okay. So let's give this a try. So I have pre-prepared this a little bit because it's, but I'll show you how to do it before I do that. So the way that we do this, let me start over. Before I start into the SpecFlow anything, we need to add a plugin to Visual Studio. So we just go to Tools and Extensions, and we look for SpecFlow. And then we wait for the super duper fast search to give us SpecFlow for Visual Studio 2015. You install that, step 1. Okay, step 2 is the NuGet package. we have to add the SpecFlow NuGet package to our particular test project. So I'm going to, again, SpecFlow, but if I just do SpecFlow, it'll return SpecFlow. I don't want that. I am using MS Test as my runner, and that makes a big difference. If you just say SpecFlow, it's going to assume NUnit. So SpecFlow MS Test, and I will get SpecFlow MS Test. And when I install SpecFlow MS Test, we'll also install SpecFlow. So this is the one we want. We're good. Golden, good. So after I got my NuGet package, then I can start writing my scenarios. So I usually put my SpecFlow stuff in a folder. It doesn't have to be called SpecFlow. It's just name that for, oops. I don't want to scope to that, but oh well, that works too. I want to add new item. And we can see now that we have this extension installed, we've got some SpecFlow things here. So there's two main things you really want to be aware of with SpecFlow. There's the feature file. The feature file is going to be the Cucumber language. The features, it's going to actually specify just one feature, right? And then there is the step definitions. And this is where we're going to set up like the statements that we saw before. This is where we're going to set up what happens in each of those statements. So we're going to start with just a feature file. And it gives me a kind of a silly little example here, right? And so I'm going to write my stuff. I'm actually going to write it here. I'm going to use another example, but we're going to use this example for a minute. And then what do I go from here? Well, we've got our feature. We've got scenarios in our feature. We're ready to start testing to see if this feature runs. The first thing I do is I come down and I say, generate step definitions. And what that will do is it will automatically create, in fact, I think I can do it. I should do it. There we go. So automatically identified all the scenarios. I only have one scenario here, but if I had multiple, it'll identify all of the different scenario statements, and it'll ask me if I want to generate them. And I want to say don't use regular expressions for the numbers, or I could do other things. And I can even preview what it's going to look like when it builds these, right? Given I have entered this regular something into the calculator. Okay, so let's generate them and we'll have a look. And then it just wants you to save it here. So I'm just going to save. This is not it. Let's see, actually add it to a project. Feature. Where did that save to? Well, let's go back for a minute. That's really not it. That's not it. Okay. Where did I save that to then? All right, let's see. All right, forget it. Come back here. Let's do the all steps are bound. Well, it must be in here somewhere. I just not recognize it because it's too ugly. No, they're not here. All right, well, let's look at a different one. I don't know how to undo the scope thing that I did. You know, I know how I can do this. Let's try and step through them. So also kind of cool, we can set breakpoints. And once we set breakpoints, we can say debug SpecFlow scenario. Of course, it didn't build, and I actually didn't expect it to build. Let's delete this guy. Delete this guy as well. And let's go on to our actual calculation feature. Okay, so this is going to talk about how to, this is a feature for score calculation for bowling, right? And it turns out there's quite a lot of scenarios, and you can see it's kind of nice that we can put a lot of data in these because it's pretty handy. So let me show you. Go to step definition. Here we go. So this is what I was looking for before. This is what it generated, but then I couldn't find. So here's our given statement. So remember, the givens are like the, there we go. Excellent. So yeah, the range in this one is we're going to set up the game. The when is like the act. Yep. And then the thens are asserts. So you'll notice kind of something that's kind of cool. See this assertion, how it's got this regex here, and then this method has a parameter? Yeah, so whatever it pulls out of the regex here becomes the parameters for this method. So those numbers become essentially arguments into this thing. And then we can say, then my total score should be, my total score should be, this is how it even generated it for you. It's kind of neat. Then we just do a simple assertion in this one, right? And then when I roll, game roll. And you'll see, let's go back to this scenario real quick. So let's see, let's pin this and go back here and find my when I roll. It automatically knew, so this is part of the language, this following series, automatically knew that I actually wanted to call the roll this many times with these arguments. Pretty cool, right? And so let's run one. So let's come back here. Here's a nice, let's do gutter ball. And let's debug this guy. So debug flow, step flow scenario. There we go, bingo. And look, F11, 11, total score should be there. And go over to my text explorer, test passed. So let's see, I can step through the code as well. So if I go to the code part of this, definition, and then I, set some breakpoints in here. There's the gutter ball one. Let's do one. Score should be. Let's run those. I think my screen resolution is too short, so the whole thing. Well, go back to the feature and then run it. Okay, so here I am. I can even step through the code part of this stuff too. So here I am initializing the game context. Here we are with my assert. We can see it passed me in 32 because that's what we were asserting. Game.score. Oops, threw an argument out of range exception. That's funny. Probably because of how we initialized logger. Nope. That's a great bug. See, we found a bug in our scenario testing. But also, you can see we've got a lot of reuse between these scenarios. And